Hey guys, welcome back. Today we're going to talk a little bit about homogeneous aqueous solutions and we're going to do some practice problems. Okay, let's get to it. So basically, this is a review from Unit 2 when we talked about solutions and mixtures. But to bring it all the way back, we need to go and explain and understand how and why water is so important. So we know that water covers most of our planet and makes up over 70% of the human body. But why is it so important? Okay. What is it about water that gives it its properties? Well, we have to start a little bit with how water is, what makes up water and how water is composed. So we know that water is made up of one oxygen atom and two hydrogen atoms. And so there's almost like a struggle. They're sharing the electrons, but the oxygen is so much, it has greater electronegativity than the hydrogen. So it pulls the electron towards it, giving it a partial negative charge. And then the hydrogens, not being as electronegative, have a slightly positive charge. And this allows water to act almost like a magnet with a positive and negative end. And it makes water polar. So because water has, so when we look at our water molecule over here, we see our big fat oxygen and our little hydrogens. And then they're sharing the electrons, as I said earlier, but they're not sharing it equally. So this makes water polar. When the electrons are shared, the electrons are shared unequally. When the electrons are shared equally, they're nonpolar. So water is polar, and because it's polar, it can dissolve anything that is also polar. So once again, just to review, that the unequal sharing of electrons between the hydrogen and the oxygen in water makes water polar. And so it's slightly negative in the oxygen end and slightly positive in the hydrogen. And so this polarity of water gives water the ability to have certain properties. So one of the properties we're going to quickly go over is adhesion. And adhesion is the ability of water to stick to other things other than itself. So if you've ever undusted at home, you will realize that it's easier to pick up dust with a wet rag than with a dry rag. And the reason for that is because, once again, the water molecules will adhere or attach to the dust particles, picking them up a lot easier. So the ability of water to stick to other things, and it's not itself, it's adhesion. Capillary action is the ability of water to move against gravity, and we see this a lot in plants, where plants will use will use capillary actions to bring water from the roots up to the rest of the tree. Cohesive forces are the ability of water to stick to itself, which is why you'll see kind of like water droplets hanging off a leaf, and you see the water droplets can get bigger, and that's because the water sticks to itself. And surface tension is another awesome property of water, which is the ability of water to kind of minimize and hold itself together and then push against the force that's being placed on it. So, for example, this allows insects and other animals like the Jesus lizard to walk on water. So surface tension is actually a pretty cool property of water. This is an example of capillary action. Another place that you can see capillary action aside from plants is if you put a paper towel and you stick it up in a liquid, you will see that the liquid will rise. And so that's water going against gravity. And in terms of chemistry, at least for us today, the most important property of water is the fact that water is a universal solvent. So because of its polarity, water is able to dissolve other things that are polar. So we have a little phrase that says like dissolves like, which means that polar things can dissolve and be dissolved in polar things. So for example, water can dissolve salt because they're both polar. However, water cannot dissolve oil because oil is nonpolar. But gasoline, which is nonpolar, can dissolve oil. So nonpolar things can dissolve nonpolar things, and polar things can dissolve polar things. Okay, so Now that we know that water can dissolve many things, when we dissolve substances, we tend to make a solution. And a solution is a type of mixture where the components are uniformly distributed. And a perfect example of a solution is sugar water or salt water. Okay, so all solutions are made up of two main parts. We have the solute, which is what's being dissolved, usually salt, sugar, Kool-Aid powder, iced tea powder, if you use powder for making your iced tea. And the solvent is what is doing the dissolving. In most cases, it's going to be water. So really quick, when you go through and I ask you which of these components should not dissolve in water. Now, we know that anything that's polar is going to dissolve. So, for example, hydrochloric acid, we know that can definitely be broken down in water. Butane, on the other hand, butane is a hydrocarbon, and hydrocarbons tend to share their electrons very equally between the carbon and the hydrogen, so we know that that is going to be our answer. All right, so here's where we come into the concepts of electrolytes. So when we talk about dissolving, at least in this unit, in terms of solutions, we're going to be focusing a lot on electrolytes. But what is an electrolyte? So an electrolyte is a compound that conducts an electric current in an aqueous solution. And you've probably heard of the terms electrolytes when you think of like some drinks like Gatorade. And in fact, Gatorade was invented in the University of Florida because the Florida Gators, which is their team, their football team over there, they were practicing, and as the athletes were practicing in the middle of the summer, they were sweating a lot and losing a lot of salts. And so they realized that the athletes were cramping up, and they came up with a way to replenish these electrolytes. So that's how Gatorade got its start, and where the common American folk became aware of the term electrolyte. So pretty much, once again, an electrolyte is a compound that conducts electric current when it's in a solution. And all ionic compounds are electrolytes because they tend to break into ions. So for example, if I take salt, table salt, sodium chloride, and I put it in an aqueous solution, and I put it in water, it'll break down into sodium ions and chlorine ions. And so each one of those can conduct electricity. All right, the non-electrolytes are things that do not conduct electricity in an aqueous. An example of a non-electrolyte would be glucose sugar. It doesn't dissociate because it doesn't break apart in water well. So it's specifically glucose sugar, and so it doesn't conduct the electricity very well. All right, so our electrolytes can be divided into two major types, which is what we consider strong electrolytes. And a strong electrolyte is one where all or nearly all the solutes exist in the form of ions. And weak electrolytes don't completely dissociate. Only a fraction of the solutes exist in the form of ions. So therefore, there isn't as much electricity being conducted, so they're considered to be weak electrolytes. And I wanted to give you an example. This is a really cool commercial from Chili's, and they were using pickles. And as you know, pickles are pretty much salted cucumbers. And they used nails and pickles. And what they did was they created an awesome show of lights. And I wanted to take a moment to share that with you. I thought they did a phenomenal job with it. I can't answer. Okay, I thought that was a really awesome experiment. Actually, it was an advertisement that, as I said, Chili's did, and I thought it was a great way to see and use, in an everyday way, how electrolytes can be used. But in terms of our bodies, your cells use electrolytes such as sodium and potassium to carry electrical impulses. In fact, the reason why your muscles can contract is because you have this thing called the sodium potassium pump, and it's going to produce these electrical currents that are going to allow for your muscles to contract and relax. When you're sweating a lot due to a strenuous exercise, your sweat is salty. You're going to lose salt. If you're crying a lot, you're going to lose salt. And so you're not only getting dehydrated, but you're losing these essential electrolytes. And so you can cramp up. In fact, lack of salt actually causes death. Most people don't know that. You think that, oh, high blood pressure, if I have too much salt, I'm going to die. But not having any salt in your diet can actually kill you way faster. So electrolytes, definitely important. All right, so now we're going to go from our electrolytes into hydrates. And so hydrates are going to be, we're going to focusing on what hydrates are. And hydrates are pretty much compounds that contain water in a crystallized form. And this water can be easily lost or gained. And so in this section, we're going to practice a little bit, and I'm going to show you how to calculate the percent of water in a hydrate. Forces that hold the water molecules together in hydrates are not very strong. So as I said before, a hydrate can easily lose and gain water. Any substance that does not contain water is considered to be anhydrous. And an meaning not, hydro meaning water. And these are some of the most common hydrates. Each hydrate has to have a specific quantity of water as part of its definite composition. And so if I take a water away, it's no longer that specific hydrate. So for example, Epsom salt, which is one that you probably maybe use in your tub to help you relax or to reduce swelling, is actually magnesium sulfate heptahydrate, which means it's made up of magnesium, sulfate, and of course, hepta meaning seven water molecules. So one of the things that you have to learn to know to do in this section is calculate the percent by mass of water in a specific hydrate. And so the way that we do this, I'm going to give you a minute to write this formula down, is the percent of mass is going to be equal to the mass of the water divided by the mass of the hydrate times 100. So let's take this example over here. Let's say there, I wanted you to calculate the percent of mass by water in sodium carbonate decahydrate. So I'm going to bring out my whiteboard and we're going to do this together. Put it over here at the bottom. And so I took off my screen so you can focus on the whiteboard. And so the first thing we want to do is we want to write down our compounds so that we know what we're dealing with. So we know that we have sodium, we have carbonate, and 10 moles of water. And so the first thing we want to do is calculate how many grams, the mass of the water. So I know that I have 10 moles of H2O, and every mole of H2O has 18 grams of water. And so I know that 10 times 18 is going to be 180 grams of water. Okay, so that's the first part. It's the mass of the water. So now let's do the mass of the entire hydrate. So now we go to our periodic table, and the first thing we want to do is, to get the mass of the hydrate. Okay, so we know we have one sodium. Actually, we have two sodium. So that's going to be 2 atoms of sodium, and each sodium is 22.9 grams. we have 1 carbon, and that carbon is going to be 12 grams. We have 3 oxygen, which are 16 apiece. And of course, we have our 180 grams from the hydrate. So we have our 10 H2O. And we've already calculated this. Now we're going to add everything together. So this is going to be 22.9. So that's 23 times 2 is 46. 12 times 1 is 12. 16 times 3 is 48. And of course, we have our 180 grams of water. So now we add that together. So we have our plus 12 plus 48 plus 180. So that gives us a total of 288 grams. Okay, so that should give us a total of 62.5 grams. All right, so that's basically I'm sorry, 62%, 62.5% of water. So that's basically how you calculate. So once again, you go through what's known. So I know the formula for sodium carbonate hydrate, and then from there, I want to calculate the percent of water. I first get the mass of the water, then I do the mass of the hydrate, and then once I have both of those numbers, it's just plugging it in. So that's going to be 180 divided by 286 times 100, and that gives you 62.9%. Okay. A way to check really quickly is that we can expect that our percentages will be greater than 50%. So if you're getting something like 10 or 12, you want to go back and check your work. All right. So here's a problem for you to calculate. I want you to go ahead and take some time and give me the percent by mass of water in Epsom salt. So I'm going to give you a couple minutes to go ahead and do that. Okay. So if you're not done, you can go ahead and pause the video and continue to work. In the meantime, I'm going to show you how we did it. So we calculated the mass of the water. Once again, I know that water is 18 grams per mole, and I have 7, so that's 7 times 18, which gives me 126. I get the entire mass of the hydrate, which is 246. Then I do grams of water divided by grams of the hydrate times 100, and in this case, it's 51.14. All right, guys, that's going to be all for today. You have a great day. If you have any questions or concerns, please send me a webmail. I look forward to seeing you in live lesson next week. You have a great day. Bye-bye.